Hello friends, you are with me in my channel Tagwork, and we are come with a new session of the Tagwork channel, Tag Lessons. In this you are going to learn so many different topics which you are studying or which you will study in the institutes, or we can say in the further life. Okay, we have a topic today, superconductor. Okay guys, here talking about the superconductor. um, the first thing comes, what is a superconductor, why superconductor is useful. But before that, we have to say that this is prepared by techberg, so please do subscribe and like and share this video for the welfare of the peoples. Guys, I have to say that please watch this video till end if you want to study about the superconducting material or superconductor. Topic about the superconductor you will learn then and then if you will watch the video till end. Because मैं आपको बता दूं कि अगर आप ये वीडियो आखिरी तक नहीं देखेंगे तो ऐसा कोई भी टॉपिक मिस हो सकता है जो कि एग्जामिनेशंस में पूछा जाए. Superconductor is a damn important chapter which is always there in the examinations like gate, entrance examination like gate, and in this year it is also related to the superconductors. The topics are also included in the JEE exams. Okay guys, so you will decide how much important this chapter or this topic superconductor is. So first of all, thanks guys to encourage me for this type of things, to do the videos related to the topics which the students and the colleagues of mine are studying. So by watching this video, at least you will grab 70% of the topic. Total 70% of the topic superconductor is included in this. This is a part 1 video. The part 2 video will be published further in 2-3 days. Okay guys, for any query please comment down. And for if okay guys, here a doubt comes with my friend that if you are going to make any kind of video that you will tell, then I will make it. So guys, without any tension, just send me, without any taking the faith in your mind, send me the topic name, I will make, and damn sure you will understand that language what I'm going to tell you. Okay, let's start with the topic superconductor. Superconductor prepared by technical bug. Superconducting materials. Talking about the superconductor have the superconductivity as the resistance have resistor have resistance. Okay, superconductor have superconductivity. What is a superconductor? Superconductor is a material that loses all its resistance. Guys, in simple language we can say that the superconductor have a property of superconductivity in which the resistance become low and up till the zero when we decrease the temperature, or sometimes what happen if we increase the temperature at the in some limit, beyond its limit. Okay, the thing comes with first with H. Cameron owns in 1908. He found pure mercury. Guys, again a superconducting material. Please listen my words. Superconductor is a material that loses all its resistance, or we can say offers zero resistance to the flow of electric current when it is cooled down to certain temperature called superconductor. Examples are, this is a author, examples are mercury Hg, zinc Zn, vanadium tin Sn, vanadium V, etc. This is a, we can say, the flow diagram. You can see K versus ohm graph, temperature versus resistance graph is here. You can see For explaining this, I have to show you a thing, transition temperature or the critical temperature. I will discuss that for that diagram in the next topic, transition temperature or critical temperature. Guys, you can denote transition temperature or critical temperature by Tc. Okay, temperature at which normal conductor loses its resistivity. Transition temperature, what is transition temperature? So at the temperature where normal conductor loses its resistivity and becomes superconductor. Guys, definite for a material, it should not be infinite, it should be finite and should be have specimen dimensions. Superconducting transition reversible, it can be reversible. Okay, superconducting transition reversible means the property, if we decrease the temperature, uh, okay, if we decrease the temperature, it can offer zero resistance, but if we increase the temperature, it can also come its normal state. Very good guys, see here, very good electric conductors, not superconductors. Very good electric conductors are not the superconductor, means that superconductors are not the conductors, good conductors. Guys, you can say sometimes we say that silver, gold, copper, they are good conductors, but we never tell them as a superconductor. Why? I show you. Guys, here you are watching that we have a superconducting material here, Hg. Okay, and you are able to watch normal, this one, normal material Ag, silver. So guys, you see that we are decreasing the temperature, guys, see, we are decreasing the temperature, but what happens, the normal metal, like we have taken the silver, the normal metal will decrease the temperature and comes with lose the resistivity, but not at the zero. It has some resistance which is known as residual resistance, which is always there at some level due to the scattering of electrons from crystal defects or the impurity added to the material. Again, if you decrease the temperature of the normal metal or the normal conductor, it has some level of resistivity, which is because of the scattering of electrons from crystal defects or some impurity added into that material. But if you see the superconductor, you will notice that superconductor, if we decrease the temperature, after some temperature, means the critical temperature or the transition temperature, it directly lose and offers the zero resistance. It means superconductor at critical transition temperature or the critical temperature directly offers the zero resistance, while normal metal will never attain that zero resistance. It has some resistance which is known as the residual resistivity. Guys, the examples of the good conductor I have already given: silver, gold, copper. And good superconductors, or we can say superconductors, zinc and palladium. At critical temperature, the superconductor suddenly achieves the zero absolute resistance. That may have said that here, at this here, the zero absolute resistance is there, which is achieved by superconductor Hg. Okay, here I forget to say that a thing that here the two types of temperatures: low Tc temperature superconductors and high Tc superconductors. There are also types in the critical temperatures. Okay, occurrence of superconductivity. These are the some examples that tin achieved the superconductivity at this temperature, 3.72 Kelvin. It's the units all are given in Kelvin. Mercury also at 4.15 Kelvin achieved the superconductivity. or superconducting state. Lead 7.19. And okay guys, we have talking about superconducting elements, but there are some superconducting compounds also: niobium, titanium, NBTI. 10 Kelvin, its unit is it 10 Kelvin unit, it achieved 10 Kelvin temperature, it achieved the superconducting material, or we can say it becomes superconducting material, or achieve the superconductivity, or achieve superconducting state. Temperature dependence of resistance. We know that the resistance is depend on the temperature. Okay guys, how it is given, and I hope that you will also know this about all the things, because you have studied this in 11th, 12th, or in somewhere else, that resistance is depend on the temperature, sometimes about the metals, about the impure metals, about the conductor alloys, that all things. Here is the formulas, or all formulas, and everything is given, that how electrical resistivity with the impurities having when high temperature is given, how when low temperature. Okay, properties of superconducting electrical resistance. Properties of superconductor electrical resistance. Okay guys, here talking about the properties. Electrical resistance. The electrical resistance of superconducting material is very low and is of order of 10 raised to minus 7 ohm meter. Again repeating the thing, the zero electrical resistance, I'm talking about zero electrical resistance or zero magnetic inductance. So here electrical resistance, okay, the electrical resistance of superconducting material is very low. It is in the order of something 10 raised to minus 7 ohm meter. Okay, defining the property critical temperature quickest test 10 raised to minus ohm centimeter. That all I'm talking about the meter, then please convert it into centimeter, then you will get that. Effect of the impurities. Here see that may I have already tell you that about the uh, residual resistivity, which is found at non-superconducting material, and at critical temperature it directly achieves the superconductor state. Effect of magnetic field. Critical magnetic field Hc. Okay guys, critical magnetic field is denoted by Hc. Now what is critical magnetic field? The critical magnetic field decreases with increase in temperature and becomes zero at critical temperature. Understanding that the critical field decreases with increase in temperature and becomes zero at zero at critical temperature. Okay, sometimes it also asks that what is magnetic field effect. Okay, so it should be said that if a sufficient strong magnetic field required to applied on superconducting, then material will be fall to its normal state. I will show that in detail. And what is mean by critical magnetic field, which is denoted by Hc. So minimum magnetic field required to destroy superconducting state is called critical magnetic field of that material. Minimum magnetic field required to destroy the superconducting property at any temperature is known as critical magnetic field. Here H0 is, let me show you the, okay, H0 is a critical field at T equals to 0 Kelvin. Critical field at 0 Kelvin. T is the temperature below critical temperature. Tc is the transition temperature or the critical temperature. This is the formula which is used in for the calculation of all these things. Okay guys, just take a view on the formula. so you will able to know what is the thing about. Guys, here we have shown that an lead, talking about the lead at 80.3 Hc. Hc again is nothing but critical magnetic field at 0 Kelvin. Guys, you are watching that, again a graph is there, critical temperature and magnetic critical field. Okay, as the temperature increases, when the temperature is decreases, the temperature when increases, the value of H0 is decreasing here. The critical field at 0 Kelvin is decreasing here. Just took it there. Effect of electric current. Large electric current induce magnetic field, destroy superconductivity. It is a simple fact that if electric current, the more electric current will move through a superconductor, then it will generate a magnetic field, and which destroys superconductivity, as we studied uh, in the 4th or 6th standard, that because of whenever some electric current is passed through someone material, it induce some magnetic field and some extra things also like flux and that all. Induced critical current, again, what is induced critical current? It is nothing but IC which is 2 pi Hc. IC is nothing but 2 pi Hc critical induced current. We can also say that critical current density, which is maximum, which is also known as maximum current that can be flow in superconducting material without destroying its superconducting state. Okay guys, it's nothing but induced critical current. Induced critical current, it means the maximum current that can be flow. जितना फ्लो हो सकता है उतना होगा, बट डिस्ट्रॉय नहीं होना चाहिए. जैसे ही डिस्ट्रॉय होने लगा तो वो काउंट में नहीं आएगा. Those which are not clear from this topic, I want to say them. The induced critical current IC is equal to 2 pi Hc, 2 pi R Hc, but here the critical current density is nothing but as maximum current can. यहाँ से यहाँ तक जितना maximum current flow होना होगा उसको वो होगा उस मटेरियल की प्रॉपर्टी को डिस्ट्रॉय करे बिना. जैसे ही प्रॉपर्टी अगर लगेगा कि डिस्ट्रॉय हो रही है तो वो काउंट ही नहीं होगा, वो इस क्रिटिकल जो करंट है उसके अंदर आएगा ही नहीं. ओके, दिस इज steady current which flow through a superconducting ring without any decrease and increase in strength even after the removal of field. The thing is same, the thing may have tell you is the simplest way to understand what is related to the electric current and the superconductivity material. Okay guys, the steady flow of current in superconducting material, the steady current of current, okay, steady current which flow through a superconducting ring without any decrease in strength. स्ट्रेंथ डिक्रीज नहीं होनी चाहिए. बाद में अगर आप जो फील्ड है उसको हटा दो, अगर आपने फील्ड हटा दी और उसकी स्ट्रेंथ डिक्रीज हो गई, इट मीन्स उसका सुपर कंडक्टिंग स्टेट भी रिमूव हो रहा है. ओके, दिस आर सम प्रॉपर्टीज ऑफ द सुपर कंडक्टिंग इन विच दिस ऑल शुड बी फॉलोड. ओके, मेसनर इफेक्ट और डायमैग्नेटिक प्रॉपर्टी. Here diamagnetic property again comes, guys. Meissner effect, diamagnetic property, we can also say that the complete exclusion of all magnetic fields by superconducting material is called Meissner's effect. What is actually the Meissner effect? See, here is a superconducting material, all the electrical fields are passing through it, should not actually यहाँ से पास हो रही है, बट इससे थोड़ा सा रिपल्स होके जाएगी. अगर इसमें से पास हो गई तो उसका सुपर कंडक्टिविटी रिमूव हो जाएगा. इट शुड नॉट बी देयर. उसमें से दूर होके सपोज ऐसे करके ऐसे जाना चाहिए. अगर सपोज ये मटेरियल है तो इससे यूं होके चले जाएगा, ये आया फील्ड यहाँ से रिमूव हो जाएगा, या यहाँ से रिमूव. इसके अंदर से पास आउट होगी ही नहीं. ओके, इसमें से पास आउट होगी ही नहीं. ओके, ये कंडीशन इज ऑल्सो गिवन. रेजिस्टिविटी इज 0. Magnetic induction B, we know that is also should be 0 when a uniform magnetic field हो. Material exhibits perfect diamagnetism or flux exclusion. Again the word comes perfect diamagnetism. Deciding property x equals to 1 by h, where this value is -1 something. When the superconducting material is placed in a magnetic field under the conditions, T should be less than Tc and H should be less than Hc. Simultaneously existence of all the conditions should be followed. Then the material should become, and we can say that it is a superconductor material. Applications of Meissner effect we can see in the maglev train. Standard test proof of the superconductor repulsion of external magnets. Levitation, and magnets levitation is nothing but maglev trains, maglev, which is used in the maglev trains. Types of superconductor. The type 1, sudden loss of magnetization, exhibits Meissner effects. 1 Hc is equal to 0.1 Tesla, no mixed state. Soft conductors. Guys, here soft conductors are not the, again I am repeating, the soft conductors are not the material having soft or having low strength. It is not that type of, it means, okay, here soft conductors are not that it have low strength or low strength. Okay, as type 2, gradually loss of magnetization, does not exhibit complete Meissner effect. 2 Hc is there, mixed state present there, hard superconductors. Okay, I show you a thing. This here it is a 1 Hc, 1 Hc. Here it is, here there are 2 Hc. See here, 1 Hc is here, again Hc is here. Here up till here it is a superconducting state, but here it is a pure form of superconductor, while here it is a mixed form superconductor and the normal state, and here is a normal state. This is a normal state. How I show you? At Hc may have said that at Hc it direct achieves zero resistance. Here what happens? Because does not exhibit complete Meissner effect, some of, suppose it has some here material here, and some lines are passing here and some are repulsion by the things. So what happens? This mixed state forms. Before that it behave like type 1 superconductor, and when all the magnetic lines are passing through that material, it achieves normal states. Okay guys, this is all about the superconductor. There are some different properties. Critical value is very low in type 1 conductor, while in type 2 conductor critical values are high because of there are two critical values. Example of type 1 is lead, mercury and zinc, while there are compounds Mb3Ge, Nb3Si, YBa2, CO3, Cu3O7, etc. are the examples. The value of Here please listen that this is an important point. The value of Hc, here Hc2, here it's given Hc and Hc1, so the value of Hc2 is 100 times greater than higher value, higher than type 1. We are talking about Hc1 now. Then Hc2, here and here, these have higher critical values than Hc1. That is why critical value is high for type 2 as compared to type 1. There are different types of conductors: low temperature conductors and high temperature superconductors. Superconductors with low temperature require liquid helium as a coolant, while they have low critical temperature Tc. Okay, here helium temperature is 4.2 Kelvin above absolute zero. As here already I have mentioned that, I have said I will come with that point. This two things, type 1 and type 2, low Tc superconductor and high Tc superconductor. What happens with low? It requires liquid helium as coolant, while high temperature superconductor, after discussing these both things, there comes with a point that why this happens with low and high. Low required, obvious, if we are decreasing the temperature we require any kind of coolant. So here helium is used, which liquid helium temperature is 4.2 Kelvin above the absolute zero. Same as well as for high temperature superconductor, there is a compound used Y1Ba2Cu3O7. Okay, O7, with we can also say YbCO or 1,2,3 compound, which is discovered in 1987. Okay, so at that time its temperature is smaller than 77 Kelvin temperature, but as the more discoveries comes, and then it comes to the superconducting oxides, the higher temperature, now it is useful in everything, so many things. There are so many applications of superconductors, which are the magnetic levitations, may have said maglev, again thing used in Jobson effect, which is Jobson junction. It is a mixture of two superconductor and one insulator between them, and so on. This is a summary of all the topics of the superconductor. So as the superconductor, may have told you about the superconductor, so this should be the material which is going to be used, or may have to say that which going to be used in future very fastly and very rarely. Today we are using that material in very rarely portion, and in future it will used for many purpose. So guys, thanks for watching my video till end. This is a lecturer, or we can say lecture type, summary type video, so it takes time to explain each and every point of view. So just clicking on the belly button to get notified about my next video related to the laser topic of the physics. In that we will cover almost portion of the laser and the so many examples we will going to do. So just watching Techbug, I think so you are going to be passed in subjects, or you will get the good marks in this type of topics. So this is our new session, so please do like, so we will get what we say that we will get some type of happiness that we are doing the right thing, and the people are what we are expecting from the people, and they are giving us better response. So do like, do share our videos, don't forget to subscribe my videos. TechBug is a channel which is giving you this kind of tech lessons which will very useful for you. So please guys, thanks for watching our video. Jai Hind, Vande Matram.